After sending the data from BeadLogic to BeadLogic, continue the analysis of your multiplex bead array data by following the tabs at the top of the screen from left to right. These include the Layout, Curve Fit, Analysis, Statistics, and Report tabs. As the initial setup was performed in BeadLogic, most of the options in the plate setup windows on the left-hand side of the screen will be unnecessary. However, they can still be used to edit various elements of your analysis. Click on the panel to expand the windows to reveal the files, which is a list of the plates that have been imported, the sample configuration, where selected wells can be defined as a standard, blank, unknown, unlabeled, or a control, the replicates window, where selected wells can be defined as replicates of a given number, the sample attributes, which are keywords that, if contained within the FCS files, can be imported from BeadLogic. Or new attributes can be created, such as gender, with a value of male and female. The dilution factor relating to the standards can also be defined here. And the analyte names can also be displayed and edited. The next step is to perform the regression analysis in the Curve Fit tab. Within this window, there are three panels: the regression curve, the regression tornado, and the regression table. The regression curve is derived from the observed values of the defined standards, and an error is calculated based on the difference between the observed value and the expected value, and this difference is reported as a percentage of the expected value, and the acceptable recovery range refers to standards that fall within this error. The regression tornado itself displays each of the standards in relation to its specific error and color codes them likewise. For example, a standard that sits within the acceptable recovery range will be colored green, and a sample that sits outside the range will be red. Standards can also be disabled by ticking the box in the Enabled column of the regression table, and standards that have been disabled will be colored black in the regression tornado plot. BeadLogic also has an auto curve fitting algorithm which will determine which standards are required to be disabled in order to have the maximum number sitting within the acceptable recovery range. To perform the auto fit, right-click on an analyte and select Auto Fit, and this will fit the curves for all of the analytes and determine which standards are required to be disabled. In this case, all standards from all analytes fit within the 30% acceptable recovery range, but you can see the effect on the curve and the tornado plot of turning off one of the standards. The acceptable recovery range itself can be changed, as too can the type of regression. The concentration units can also be redefined here, and to create a report for the regression analysis of each of the analytes, right-click on an analyte, select Send All to Report and Default Analyte Report. And to view this report, click on the Report tab, and as you can see, the regression curve, tornado, and table is displayed for each analyte. Right-clicking on any of the elements provides a window where various formatting options are available. These format options can also be applied to all elements at once. Continuing with the analysis now, we have defined the layout, fitted the curves to the standards, and the next step is to analyze the data. So in the Analysis tab, we have the Table Setup window, the Data table, and the Quick Heat Map window. There are three levels of analysis available here: Basic, Intermediate, and Advanced. And these relate to the level of sophistication available with filtering and grouping the data based on keywords or attributes and statistics. Within the Basic options, select the values that you wish to display, for example the fluorescence intensity, the observed values, the observed with limit, where any unknowns that sit above or below the highest or lowest standard are given the same value as that standard, the observed in range, where any observed values for the unknowns that exist above or below the highest or lowest standard are defined as being out of range, and then there is also the bead count. Statistics such as the mean, the percentage CV, standard deviation, min, max, or the sum of the values, if there are replicates, can also be displayed. In the Quick Heat Map window, a heat map is created based on the values defined in the table setup window. The heat map can be coloured by way of a number of presets from the drop-down menu, and it will be updated to reflect any changes made in the table setup window. Clicking on any of the heat map column titles will sort the samples from high to low and low to high, and the heat map itself, with its displayed colouring, can be exported by right-clicking and choosing Export Heat Map. In order to filter or group the data in preparation for graphing and statistical analysis, click through to the Intermediate tab. Here, there are more options to define which datasets are displayed. For example, individual analytes can be disabled, and by clicking on the analyte in the window, a filter mode and value can be set. For example, all samples with a concentration higher than 1200 picograms per mil. Multiple levels of filtering can also be created. For example, I can select another analyte, choose a new filter mode, and a new concentration value, and the results will be updated in the table below. I can edit any of these filter modes, or in this case, I can set the filter modes for both analytes to none. And this will take me back to my original table, displaying all analytes. In addition to filtering, samples can also be grouped based on one or multiple keywords. To group a set of data, choose an option from the Group By drop-down list. The format in which the data is displayed in the Analysis tab is the same as it will be displayed in the Statistics tab, where the data is then graphed and statistical tests can be performed. And this is why it is important to group the data appropriately to obtain the desired graphs. So here you can see in the Statistics tab, the data is a reflection of the selection made in the Analysis tab. So, to change the data displayed in the Statistics tab, return to the Analysis tab and update the selections. Back in the Statistics tab, use the toolbar options to define the table grouping and analytes to be displayed. Then right-click on the Graph tab in the Graph Data window to view the result in the workspace. A number of formatting options can be accessed by right-clicking within the Graph window, such as changing the angle of the axis labels. Each graph also has a side drawer where the graph type can be changed, and a range of other formatting options are available. The graphs themselves can be renamed by right-clicking on the Graph tab in the Graph Data window and typing in a new name, or alternatively, use the arrow buttons in the toolbar or the drop-down list to display a different analyte in a graph with the current settings. To preserve a current graph and create a new one to display a different analyte, click the Clone button. This will add a new graph in the Graph Data window, and then a new analyte can be chosen for this cloned graph. Again, format the graph by right-clicking on the graph itself or from the options in the graph side drawer. Statistical tests can be performed on the data used to create the graphs. To perform statistical tests, choose the Analysis tab, and then from the drop-down list, choose the specific statistical tests, and then select the groups that you want to compare. The results will then be displayed in the description window to the right. The final part of the analysis is to generate a report. In the Report section, click on the various tabs in the window to the left to select elements to add to the document. The first tab, being the Documents tab, is where new documents can be created, and the format of the selected document can be defined. For example, I can switch from grid to free layout. Now I will add some elements, the first being the Well Data table from the Plate Layout section located under the Plates tab. As you can see, an additional page is added to the end of the report, and this will grow as more and more items are added to the report. Now, from the Data tab, I can add the heat map that was generated in the Analysis section. I can format this heat map by right-clicking and choosing options from the available menu, such as selecting the colours that make up the heat map gradient. A similar right-click menu is displayed for all elements, however the options available are specific to the item itself. In addition, the same formatting options can be found, by clicking through the tabs on the left-hand side until you reach the Properties tab, where all the formatting options can be visualized without having to access them through the right-click menu. From the Data tab, I can import the graph that I created in the Statistics section, and this is more easily identified as I rename the graph. And from this same tab, I could also import the Statistical Analysis Summary table. Associated keywords can also be added, as can the worksheets, which contain the data from which the graphs are derived. Finally, reports can be annotated using various tools in the toolbar. This includes adding text, shapes, arrows and lines, time and date stamps, or even importing pictures. Reports can also be displayed as a slideshow, or exported and saved as a PDF file.